Numbers are the universal language, a bridge that connects us all. They transcend time and culture, uniting humanity in a shared understanding. From the earliest humans tracking the phases of the moon to modern physicists grappling with the mysteries of the cosmos, mathematics has been our constant companion. It has guided explorers, informed philosophers, and inspired countless innovations. It is a journey that began with simple counting and has led us to explore the very fabric of reality. The evolution of numbers is a testament to human curiosity and ingenuity. Our ancestors, long before the invention of writing, left behind evidence of their early mathematical endeavors. These marks and symbols were the first steps in a long journey of discovery. These were not abstract equations etched on stone, but rather practical tools and markings that hinted at a burgeoning understanding of quantity and shape. They used these tools to solve everyday problems, from trading goods to measuring land. The need to count, to measure, and to make sense of the world around them laid the foundation for the incredible edifice of mathematics that we marvel at today. And this need drove innovation and led to the development of more sophisticated mathematical concepts. This essay explores the fascinating journey of mathematics from its humble beginnings to the dawn of abstract thought in ancient Greece. It is a story of human perseverance and the relentless pursuit of knowledge. We will trace the development of numbers, geometry, and early mathematical thinking across different cultures. Each civilization contributed uniquely to the tapestry of mathematical knowledge. Join me as we delve into the minds of our ancestors and uncover the ingenuity that laid the groundwork for the mathematical language we speak today. Together we will explore how these early innovations have shaped our modern world and continue to influence our understanding of the universe. The earliest form of counting was likely as simple as it gets, using one's own fingers. This method, while rudimentary, is inherently intuitive and forms the basis of the base 10 system that many cultures, including our own, use today. From ancient times to the present day, the act of counting on fingers has been a universal practice. Children around the world still learn to count this way, connecting us to our distant ancestors. However, as societies grew and the need to count larger quantities arose, fingers alone proved insufficient. Imagine trying to keep track of a large herd of animals or a bountiful harvest using just your fingers. It quickly becomes clear that a more advanced system was necessary. Our ancestors needed a way to record and remember numbers over time. To overcome these limitations, our ancestors turned to more permanent and versatile tools. They began using stones, sticks, and bones to keep track of numbers. These tools allowed them to record quantities and perform more complex calculations. One of the earliest examples of such a tool is the Lobombo bone, a baboon fibula dating back over 40,000 years. This bone, with its 29 distinct notches, is believed to have been used as a tally stick for counting. Discovered in a cave in Swaziland, the Lobombo bone provides a fascinating glimpse into the early human need to quantify and record information. The notches on the bone suggest a methodical approach to counting, indicating a significant leap in cognitive abilities. Another compelling piece of evidence is the Ishango bone, found in present-day Congo and estimated to be around 20,000 years old. This bone features a series of markings arranged in groups, hinting at a more sophisticated understanding of numbers beyond simple tallying. The Ishango bone's markings are particularly intriguing because they suggest an early form of arithmetic. Some scholars believe these markings represent prime numbers or even a rudimentary lunar calendar, indicating a deeper comprehension of mathematical concepts. The idea that early humans could have been tracking lunar cycles or identifying prime numbers is a testament to their intellectual curiosity and ingenuity. These ancient artifacts, though simple in appearance, provide a profound glimpse into the minds of our early ancestors. These tools and artifacts reveal that the drive to count, to quantify, and to make sense of the world through numbers is deeply ingrained in our nature. They show that even in prehistoric times, humans were developing the foundations of mathematics. From fingers to bones, the evolution of counting reflects our innate desire to understand and organize our environment. This journey from simple finger counting to the use of sophisticated tools marks the beginning of humanity's long and ongoing relationship with numbers. Around 3000 BC, in the Fertile Crescent of Mesopotamia, a new chapter in the history of mathematics began. This region, nestled between the Tigris and Euphrates rivers, witnessed the rise of city-states and the development of writing. With this newfound ability to record information came an explosion of knowledge and innovation, including significant advancements in mathematics. The Sumerians, known for their ingenuity and organizational skills, developed a system of writing known as cuneiform. Using a wedge-shaped stylus to make impressions on clay tablets, they recorded everything from business transactions to epic myths. Crucially, cuneiform also became the vehicle for expressing their mathematical ideas. The Sumerians' contributions to mathematics were profound. They developed a sophisticated number system based on the number 60, a sexagesimal system that we still see echoes of today in our measurement of time and angles. This system allowed them to perform complex calculations and to develop a deep understanding of arithmetic and geometry. Section 4. Numbers take shape cuneiform and the power of 60. The Sumerian number system expressed through cuneiform was a remarkable achievement. It was one of the earliest forms of writing and numerical representation, showcasing the ingenuity and sophistication of the Sumerian civilization. They used a combination of two symbols, a vertical wedge representing 1 unit and a horizontal wedge representing 10 units. This simple yet effective method allowed them to create a wide range of numbers with just a few basic symbols. These symbols could be combined to represent any number up to 59. By arranging these symbols in various combinations, the Sumerians could perform complex calculations and record large quantities of data. For numbers greater than 59, they employed a place value system, a revolutionary concept that formed the basis for all subsequent place value systems, including our own decimal system. This innovation allowed them to represent very large numbers efficiently and accurately. The choice of 60 as the base for their number system might seem peculiar at first, but it actually offered several advantages. The number 60 is highly composite, meaning it has many divisors, which made it extremely versatile for various mathematical operations. 60 is divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, making it highly adaptable for various calculations and divisions. This made it easier for the Sumerians to perform complex mathematical operations and solve practical problems in their daily lives. This flexibility proved invaluable for trade, astronomy, and other practical applications. The ability to easily divide and multiply numbers by 60 allowed the Sumerians to develop advanced systems for measuring time, land, and other quantities. The legacy of the Sumerian sexagesimal system is still evident today. Our modern timekeeping system, which divides an hour into 60 minutes and a minute into 60 seconds, is a direct descendant of the Sumerian system. We divide an hour into 60 minutes and a minute into 60 seconds. This system has been so effective and enduring that it has remained largely unchanged for thousands of years. Similarly, our system of measuring angles in degrees, with each degree subdivided into 60 minutes and each minute into 60 seconds, can be traced back to the ingenuity of the Sumerians. Their contributions to mathematics and science have had a lasting impact on the world, influencing countless generations and shaping the way we understand and interact with the universe. Section 5. Geometry in the Desert, Pyramids and the Practical Art of Measurement. While the Sumerians were developing their sophisticated number systems and exploring the intricacies of arithmetic, another civilization was making remarkable strides in geometry, the ancient Egyptians. Egyptian mathematics was driven by practical needs, particularly in the realms of construction, surveying, and astronomy. The construction of the pyramids, those enduring symbols of ancient Egyptian civilization, is a testament to their advanced understanding of geometry. The precise alignment of these massive structures with the cardinal points and the accurate proportions of their triangular faces required a deep knowledge of angles, triangles, and spatial reasoning. Egyptian surveyors, known as rope stretchers, played a crucial role in land measurement and the re-establishment of boundaries after the annual flooding of the Nile. Using ropes with knots at specific intervals, they could measure distances, calculate areas, and even determine the right angles needed for accurate land allocation. Section 6. the Nile's numerical flow, Egyptian mathematics and its applications. Egyptian mathematics, as documented in surviving papyri, reveals a practical and problem-solving approach. They developed methods for calculating areas and volumes essential for land measurement and the construction of granaries and other structures. Their calculations were not based on abstract formulas, but rather on a series of step-by-step procedures, often involving doubling and halving to arrive at the desired result. One notable example of Egyptian mathematical thinking is the Rhind mathematical papyrus, dating back to around 1650 BC. This papyrus contains a collection of 87 problems and solutions covering a wide range of mathematical topics, including arithmetic, geometry, and even simple algebraic equations. These problems offer a fascinating glimpse into the everyday applications of mathematics in ancient Egypt. From measuring the inundation of the Nile to constructing colossal pyramids, mathematics played a vital role in the flourishing of ancient Egyptian civilization. Their practical approach to problem-solving and their impressive feats of engineering stand as a testament to the power of applied mathematics.